Line of sight is a game mechanic where enemies can only detect the player if they're within a certain angle and distance in front of the enemy and not hidden behind any obstacles, and it's commonly used in games like Hitman, Portal, Mark of the Ninja, and many more. In this tutorial, we build this mechanic in PyGame in a simple demo that includes a controllable player and turrets that will target the player if they're within their line of sight. We'll also add the ability to place down obstacles that the player can use to hide behind. I'll be using free sprites from Kenny's asset packs. Links are in the description and in the GitHub repo, along with all the code and images. Before we begin, this video assumes you have some basic knowledge of classes in Python, as well as knowing some simple trigonometry and vectors. Let's get started by setting up our scene. If you've already done this, you can just skip to this timestamp. We start by importing PyGame and then calling pygame.init to initialize all of the PyGame dependencies. We then define the width and height of our window, and subsequently create the window using pygame.display.setMode and give it width and height as an argument inside of a tuple. Afterwards, we create a clock using pygame.time.clock and make a constant for our frame rate. We'll then make a variable called running set to true and make a while loop that runs so long as running is true. This will be our main game loop. Inside of it, we'll run over all of the events from the current frame. If any of them are from the player trying to close the game, we'll set running to false. We'll then clear the entire screen. Here I'm doing so using a dark green color to mimic grass. And at the end of each frame, we update the display using pygame.display.flip and call clock.tick with our FPS as an argument to make sure that we're running the game at a fixed frame rate. After we've quit the main game loop, we call pygame.quit to clean up all of PyGame's dependencies. At the end, we should get something like this. Now that we're ready to implement other features, let's start with the player. Before anything else though, we need to import the math module. This will come in handy later. Then we'll load in and store the image for the player. We'll also call .convertAlpha on this object to make sure that any transparent parts of the image are handled correctly. Then we'll create a vector too to store the position of the player and set it to the center of the screen. We also make a variable that will store the rotation of the player, and for now just set that to be 0. We'll then create a function that will calculate the position and the rotation of the player. We'll then create a variable for the speed of the player, and then load in all of the keys that are currently being pressed using pygame.key.getPressed. Given this, we can create a two-dimensional vector that points in a direction that the player wants to move, where A and D are for horizontal movement and W and S are for vertical movement. I'll then create an if statement that checks that the vector isn't 0, meaning that the player actually wants to move this frame. If that's the case, we'll calculate the new position by first normalizing the direction vector so that it always has the same length, and then multiplying it by speed, and then adding that to the old position of the player. We also calculate the new rotation of the player by taking a tan of the direction vector. This works because we can think of the direction vector as a right triangle where the x and y components are the side lengths. Taking the tangent of this angle then gives us the y component over the x component. That's why if we take the inverse tangent of y over x, we're left with the angle. Using the atan function gives us the angle in radians though. However, PyGame needs that angle in degrees. Because of the way angles are also used in PyGame, we also need to negate the result. Finally, we return the new position and the new rotation inside of a tuple. If the player didn't move, however, we just return the old values. Inside of the main game loop, we now call this function and use it to set the new position and the new rotation. After we've cleared the screen, we can now calculate the rotated player sprite by calling pygame.transform.rotate and pass it the player sprite and the player rotation. We also need to calculate the rect of this sprite, and we do that by calling rotedPlayer.getRect with the argument of center equal to the player position. Finally, we draw it to the screen using screen.blit and pass it the rotated player sprite as well as the rect. When we run this code, we now have a player we can move around the screen that rotates accordingly. Now let's create the obstacles. To do this, we first create an empty list called obstacles, and then we create a function called createObstacles that takes in one argument called position. Inside of this function, we'll first load in the image and then again use convertAlpha. We'll also create a rect for this image and set the center to the position that we passed as an argument. At the end, we append a tuple consisting of the image and the rect to the obstacles list. Inside the game loop, we'll check for new event type, this time pygame.mouseButtonDown. This event is fired when the left mouse button clicks down. If we get this event, we call create obstacle and pass the mouse position as an argument by using event.pos. Now we just need to draw the obstacles to the screen. We do this by calling screen.blitz and just pass it the obstacles list. When we run this code, we should now be able to click on the screen to place down the obstacles. The player is currently able to just walk right through them though, but collision detection is something that's outside the scope of this video. Now we can finally create the turrets. At the top of our file, let's create a new class called turret. The init function of this class will take in the position of the turret, the starting angle, the maximum distance that the turret can see, as well as the maximum angle that the turret can spot the player from. We'll store all of these as attributes inside of the class. In this demo, I'm drawing the turret using two sprites. First, the stand at the bottom, and then the gun which rotates on top of that. Therefore, at the end of our init function, we'll load these two sprites separately. Now let's create a method inside of the class that draws our turret to the screen. We'll call the method draw and make sure it takes in the screen as an argument. We'll make sure to first split the stand and then get the rotated gun sprite and draw it on top of the stand. Let's now create an instance of this class right underneath our obstacles list. I'll set the initial position to 200, 200, the initial angle to 0 degrees, the maximum distance to 250 pixels, and the maximum view angle to 90 degrees. Inside of the main loop, we'll now call the draw method on this object. Now we can see we have the turret drawn on screen. In the finished demo, I also draw a visualization of the area that the turret can see. I won't go too much into detail in explaining how that works, but if you want the same thing, feel free to pause the video and copy the method I have here. Make sure to also call it inside of the draw method for the turret. Now let's make the turret be able to detect the player. Inside of the turret class, let's create a new method called canDetectPlayer. At the start of this, we'll calculate the vector from the turret to the player. If this distance is greater than the maximum viewing distance of the turret, we immediately return false. We then calculate the viewing direction of the turret. We'll get the x component by taking the cosine of the angle, and the y component by taking the negative sign of the angle. Then we use one of PyGame's built-in vector functions to get the angle between the turret's viewing direction and the vector to the player. We want this angle to be between negative and positive 180 degrees. However, this function returns values all the way from negative 360 to positive 360 degrees. Therefore, we add this if check to make sure that it's in our desired range. We can then check if the player is outside of the maximum viewing angle, and if they are, we return false. We then loop through all of the obstacles and check if the line from the player to the turret intersects with any of them. If they do, we return false. Finally, if we have passed all of the checks, we return true. Now that we can check if the turret can see the player or not, we can create a function that updates its rotation if it does. Let's create a method called updateRotation. Inside of it, we'll check if the turret can see the player, and if it can, we update the rotation of the turret to the angle from the turret to the player using the same bit of maths that we did previously. In the main loop, we'll now call this updateRotation method right after we've updated the player. Now we have a full working demo of the turret that tracks the player if they can see him, and the ability to place down obstacles to block their view. Thank you so much for watching. If you found this helpful, please consider leaving a like, subscribing, or even dropping a comment if you have any questions or suggestions for future videos. And hopefully I'll see you in the next one.